Time to implement interp. We've got our 4 arguments on the top, and the first thing we do here is create a helper function called recur, and we use this to recur on a new expression while keeping the same arguments, classes, same this, and same argval. A few of the cases here are pretty straightforward. So for int expressions, we have an int value. For plus and mul, we recur on the sub-expressions and then call a helper. For this and argy, we just return the corresponding input to interp. The more interesting cases start here with new. New takes in a class name and expressions for the fields. We use a helper function find to look up the class value that matches that class name. This find is just like the environment lookup we've been using all semester. Second, we need to evaluate all the field expressions, and we can do that with our recur helper. Now it's time to initialize an object. In the end, we want to create an object V with the class name and those field values. Before we do that, there's one thing we need to check. We need to make sure that the length of the values matches the length of the field names in the class C. If we have a match, we return the object V. If we don't have a match, we have an error. A get expression looks up a field inside of an object. First thing, we need to recur on the object expression, check if we have an object V or if we need to raise an error. And then in the object case, we have a sequence of field values, and we need to figure out which one of those values corresponds to the field name that we've been given. The answer to that question is inside of the class. We need to use the class name to look up the class value. We call find and then unpack the class that we get as a result. And the final step is to match up those field names with the current name and extract the corresponding value. We can do that with find as well. We just need to use map2 as a first step to create a list of pairs where the first element is a field name and the second element is a field value. A sendee is a method call. We have an object expression, a method name, and an argument expression. We need to recur on the object expression and argument expression. Then we need to check that the object expression really returned an object. If not, raise an error. And now we need to find the method body that corresponds to that method name and start interpreting the body with this argument value. The way to do that is to use the class name to look up a class definition. Then inside the list of methods inside of that class, find the one that matches the method name. We'll put all that together with a helper function, call method. Let's look at call method next. We have a class name, method name, list of classes, an object, and an argument value. We can use find to search the list of classes using our class name, then unpack the result to a class C. That gives us the list of methods. Now we need to use the method name to search inside that list of methods. That second call to find gives us a body expression. Finally, we interpret the body with the list of classes, the current this object, and now with argval as the input to the method. There's one more case left inside the interpreter, and that's for a static send. Here we have 4 items to work with: object expression, class name, method name, and arg expression. The method body that we want comes from the class that matches class name. Just like with a regular send, we need to recur on the object and the argument expression. This time, we don't need to use the object to look up the method body. Instead, we go directly to the call method helper function. We use the class name that's from the static send to do the lookup, and that will give us a body to interpret in the context of obj, the object, and the argument value. The thing that makes sSend a static send is that we can figure out which method it is without depending on the object. We only need the class name, and since the class name is known statically, we could do this lookup ahead of time.